So this is Geometry, Semester 1. It's the unit called Similarity. It's the first lesson called Proportional, Proportion, Proportions, Practice. So those are all variations of the same word, right? Either a noun or proportional being a characteristic, and proportions, another way of saying a noun, right? Multiple with plural. We're going to talk about all that in this lesson. It's on creatormath.com under the Geometry tab. You may have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So before we get to the problems, I usually, not always I guess, but usually I try to preview for you where those notes are because this is not always easy for students to find. So let's see if I can get there in a reasonably quick fashion. And so on all these videos, we're going to do a problem set, but you need the notes in your comp book. Otherwise, the problem set doesn't make much sense to you, right? You need some basis for this. So a lot of the notes you can take on your own. And then when we get to this explanation, then they make more sense to you, okay? Well, here's the name of the website, creatormath.weebly.com. When you get there, which hopefully you can by Googling that, you should see this homepage. All right, scroll for anything to do with the comp book, because every time, students get lost in the comp book. They're like, I don't understand the requirements. So go to the homepage, scroll all the way down. Well, it's not very far, until you see large letters, composition book. Once you see that, look for the picture. Here are, a bunch of videos. Watch all the videos. Here are due dates. Follow the due dates, and here are instructions what to put on which pages, right? Follow all those directions. If you do that with your comp book, and there's a video on how to number pages, etc., right? You should have a 90 or 100% on your comp book, and you submit that by video to the LMS Information Learning Management System, right? We're looking at a geometry lesson. So all of the lessons, the vocabulary, the problem sets, and the videos, instructional videos, are all under the tab of the class you're in this case, geometry. So let me please point out to you the Vocabulary Geometry Practice Study PDF. This is a complete list of all the vocabulary we'll use the entire year. It is searchable, you guys. Download it to your device. Google, how do I search a PDF on whatever device you're on? It's different for each device, so just look up yours. And you're going to be able to get 100% or very close to it on all of your vocabulary practices. And that's going to help you understand some of the background. So now we're going to scroll down to the table of contents, we call it. For the semester we're in, please pay attention to that. And this video happens to be for this semester, semester 1. It's geometry table of contents, and this should have been written by you on pages 2 through 6 of your comp book. Please see the directions back where we just were. And please write all these lines in, and it has all the page numbers for where everything goes in your comp book. This is how you understand what do I put on which page. By the way, there's a video on how to number the pages of your comp book. Watch that. Watch the videos back on that prior page, that home page, and you're going to hopefully understand a lot more clearly what's involved in getting that A on that composition book and helping yourself understand a lot of the topics we're going to cover. So we're going all the way down to Unit 8. Okay, where is it here? Here's congruence. Here it is, similarity. This is Unit 8. So in the similarity unit, there are 1, 2, 3, 4, 5 lessons. Each one of these is a lesson. Actually, I'm down a little low. Let me go back up and find it up here. Here. So similarity, here it is, 1, 2, 3, 4, 5. This is the title of the first one we're looking at, proportional, proportion, proportions. Here are the page numbers that these notes go on in your comp book. Please don't take this video's word for it, but go back and find the original table of contents. At the time you're watching this, probably these page numbers will have changed, right? We're going to click Notes. Here are the problem sets we're going to do. We already printed one out, but you don't have to print it out. You can probably just look at the video solutions, which we'll attach this video to right here. So when you open Notes, sometimes it takes twice. This is what you're copying into. You should be able to enlarge them. You're going to copy all these notes into those pages we discussed in your composition book. So we're talking about nested right triangles here. This is a method of proportionality. Proportional is like a scale model. This smaller triangle right here is nested into a larger triangle. See the two of them? Big one and a small one. Because they share the same angle here, these become similar. Similar means proportional, and we always pull out one of our models, and this case it's a model helicopter we have. This is what is this one? This is a Dolphin, an aerospatial Dolphin, and spelled D-A-U-P-H-I-N, so I can't quite say it right, but Coast Guard uses these. Kind of cute because it sounds like dolphin, right? So a Dolphin, that might be in another language actually, because the aerospatial company, helicopter company, is in Europe, and some of these helicopters are made in different countries. The real ones, that is. This model is, I don't know where it's made, probably. Anyway, this is a 1/48 scale, so proportional means scale model. This is a scale model of a triangle right here. This is a smaller one. It's a scale model of the larger one. Or the larger one could be called the scale model of the smaller one. These are related by a scale factor, and we can use a proportion, is one fraction made equal to another, to solve these. And we're going to show that in the problems we do. Write all these notes into your comp book, please. Explore the different proportions that we have. There's options there. Explore the vocabulary. What does proportional mean? Also called similar in geometry. It's smaller or larger by a scale factor. Proportion, one fraction made equal to another. Symbols. The symbol for proportional is a squiggly line. Symbol for congruent is an equals with, and congruent, by the way, means exactly the same shape and size. Proportional means exactly the same shape, but different size related by scale factor. So scale factor, the factor enlarged or shrunk. So this scale model was shrunk by 48 times. We took the original helicopter and each piece of it, each dimension of it, we divided by 48 and built this one that now looks exactly like the original. Right? But it's smaller by a scale factor of 48. 1/48 in this case because it was shrunk. So we're going to use cross multiplying to solve these. And this 3 dots here, we'll put other things in the vocabulary. 3 dots in math means therefore. So sometimes you just see 3 dots and you're like, what is that? You got to know what it means therefore. All right? There's some problems to put in your comp book for these. Go ahead and do that and then do these problems. So let's see what they've got for problems. First things first, what does congruent mean? So congruent means more than equal, all right? More than equal, or I like to say multiple aspects of equality. If you're asking, is this triangle exactly equal to this one, or are they congruent, you're looking at angles, corresponding in this case, which are matching locations on different shapes, and side lengths. So it's not just 3 equals 3. Like 3 equals 3 would say 3 equals 3, right? But now we're asking, is this shape equal to this shape? You got to consider the angles, and you got to consider the side lengths, right? So that's multiple aspects of equality, and that's why I like to say it is congruent. That's what congruent is, multiple aspects of equality. But it means exactly the same shape and exactly the same size. So equal corresponding angles and equal corresponding side lengths. What does proportional mean? So now we're talking about proportional in this lesson. We're talking about similar. So larger or smaller by a scale factor called similar in geometry, and that's our scale model helicopter, is proportional, and we will use a proportion to solve it. What is the symbol for congruence? It's right here. It's an equal sign with a squiggly line over it. Just, remember what it is. What is the symbol for similarity or proportional? It's a squiggly line like that, and it kind of goes like that. It's probably a better. And this one too, if I could draw it a little bit better. It looks like the squiggly line looks more like that. Search it out on your keyboard. It's in the top left corner as one of these squiggly shapes, if you've got a keyboard you're looking at right now. All right, with that, let's look at a couple nested right triangles, which are going to be similar. So what happens is we've got a triangle here, a smaller one. You can see it. It is a right triangle. There's a right angle right here. This is it here. I redrew it here. Then there's this larger triangle going on, and these are called nested. So the larger one goes out. They both go out to the same distance here. This one's larger, like this, and this is a right angle. So nested because this one is nested into the larger one, or put inside of it, I guess is a way to say other than nested. Nested may not make that much sense. But it says, given the following nested triangles, identify the correct proportions. More than one answer may apply. So let's take a look what they've got. AB over CD. Let's just rewrite that. AB over CD, because you're going to have to slow your brain down on these. Whoops. AB over CD. Okay, I'm going to mess it up right from the beginning. It's going to be hard to understand. So let's map out where this is. Here's AB. it's this back side of this larger right triangle, and CD is here. It's this side of this triangle. So this side of the big one, this side of the small one. So we're comparing one on top of the fraction, one below. We're going to put that equal to another. This is called a proportion. One fraction made equal to another. These are fraction bars. This is an equal sign. And if we went from one to the other, now let's see what they picked. They picked BE for the top here. If they picked BE, here's BE, this whole distance here. So if it's this side of the longer one, it's going to be this side of the shorter one, which is DE. Okay, we're just matching up corresponding locations, putting them consistently into a proportion. So AB over CD is equal to BE over DE. Sure enough, this is correct. Let's try the next. What they've done is flipped it, because they're trying to show us some things about a proportion. We can flip this. So see how the CD is now in the numerator position and the AB is now in the denominator position. So let's trace back through it. So now we have CD is here. So the small side over the larger side. And now if we're going to go the same route, let's put the DE on top. And I already see that this is going to be up in the numerator position, so the BE is going to be down in the denominator. So does that match this one, DE over BE? Yes, it does. So these two are correct. So we've got the two that are correct, and there could be more proportions. You can do generally 4 or 5 on these cases. And we're not going to go through them all. We'll just go through the basics at first here. Let's look at one that's wrong. This is DE over BE. So let's try DE over BE equals, right? So DE, here's DE. So we're doing this one over BE, which is the long. So small over larger. So once we went that direction, let's see what this is. If you put a CD here, where's CD? CD is now this one, right? So if we went small to large, we would go small to large. CD over AB. Well, looks right too. So CD over AB. Let's do it one more time. DE. So here's DE from here over BE. So this over this is equal to this over AB. Yeah, I'm okay with that. This one's right too. I guess maybe we did show them all here. Let's see what the next one is. DE. So you're just going to go through these one at a time, and you got to be patient and slow down. You can even see we're looking at them, right? And they put a BE on top. So DE over CD. So DE over CD. So this side of the small to this side of the small would be this side of the big to this side of the big. So BE over this side is AB. All right, is that what they have? BE over AB. Sure enough, this one's right too. So I see where we're headed here. See this one? All right. Let's move this up a tiny bit, and let's write another one here. So here's the last one. DE over AB equals. So here's DE, this one, over AB, over this one. So look, here, over here. Now this is very interesting. This one's, I wouldn't do it this way, but it works this way, right? So let's try it. DE over AB. If we went that direction, we went this side to this one. Now, probably we're going BE, we're going large to CD here. So we went small base to large height, right? DE to AB. Small base to large height. Now we would go large base, BE, to small height, right? CD. I'm okay with that too. It's the same order, it's going to work. And one of the ways to check these is to, I'm not sure I like that one. That kind of reverses. Let's do it one more time. DE to AB, right? Small base to large. Now we would go large base, BE, to small height. So BE to CD. BE to CD, DE. Yeah, and notice we can reverse this one. Okay, let's cross multiply. So let's move one of them. Let's leave the DE on the top and move the BE here. Okay, say equals. Now move the CD up here. Can you still see it? Come on. And then move, and if the CD moves here, we kept the DE here, so we'd keep the AB here. Isn't that what we have? CD over AB and DE. So this one's right too. These are all correct, you guys. It's going to be one answer. They're all correct. All right, so let's go ahead and look at the next. And these are going to challenge you a little. And when it's mixed up like that, we went in the same pattern. We went base of the small to height of the big. So then we went base of the big to height of the small. If you notice, it's the same pattern we repeated in one fraction made equal to the other. And that's how proportional triangles work. You can switch those as long as you're consistent in your order. So I kind of think I see where this is headed, right? Let's go ahead and jump straight to this one. Let's do AB over DE. Let's go in reverse order now. Let's go with this one. Is it CD over BE? So AB, height of big to DE, to this base of small. If that's true, I would go height of small, CD, to base of big, BE. And isn't that CD over BE? So this one's right, right? These are all correct. You see where we're headed here? You're going through each and every one. Let's go through the next. DE over CD equals. And they get easier. This is probably the hardest one because it's kind of in a mixed up order for the way our brains think, but it works because we stayed consistent between the two proportional triangles. So if this is DE over CD right here, DE over CD. We went base of the small to height of the small. Now we're going to go base of the big, BE, to height of the big, AB. So BE over AB. Check. Check. Both of those. Let's do it again. DE over BE equals. So we went DE, here we are here, DE over BE. So DE over BE. Base of the small to base of the big. Let's go height of the small to height of the big. And I hope you can hear me saying them in those orders. Here it is, CD over AB. This works too. Check, check, check. Let's do it again. CD over AB equals DE over BE. All right, so let's check it out. CD is here. Height of the small, height of the big. Base of the small, DE, check, over base of the big, BE, check. This one works too. Let's check one last one. Let's do it up here, AB. So 1, 2, 3, 4, 5 different proportions are acceptable, and you might even be able to find a few more if you rearrange these a little bit more, okay? But this is good enough for now. And I'm hoping the illustration you take away is just the power of proportional shapes and the power of how now you can keep switching around. And as long as you look at a consistent, like if you go small to big, you go from the model to the big of 2 different parts. They will be equal to each other where one fraction is equal to the other because it's a consistent scale factor. Okay, so AB over CD equals BE over DE. AB over CD. So height of big, height of small. So let's do base of big, BE, check, over base of small, DE, check. This one works too. It's all of the above. All right, how many more of these do they give me? Just one more. Thank goodness, because it's taken me a while, right? Because you're going through each and every one of the answers. So I'm pretty sure I know it's all of these. I mean, part of these practice sets are geared toward allowing students to write, explore, and to kind of repeat a little bit, slowly but surely. And only 7 problems, thank goodness, but each one has kind of 1, 2, 3, 4, 5 parts each, if you really think about it. Let's start at the hardest one, I think, this one. Excuse me. AB over CD equals DE over BE. Okay, let's check it. So here's AB. AB over CD. Height of the big, height of the small. If that's true, DE is height of the big over height of the small. Wait, DE is base of the small over base of the big. That went in reverse order. This is not right. Height of the big, height of the small, it would be base of the big, BE. It would have to be BE over base of the small, DE. Let me try one more time to explain it. We're going height of the big to height of the small. We better go base of the big to base of the small. We must stay consistent. This one's wrong. It's out. All right, let's try this one. So I like that. They mixed it up on this last one and they gave us some wrong answers to find. Okay, so let's do DE over CD. DE over CD. So base to height, we're now going to go BE to AB. This is right. Try it again. DE to CD. Now we're going to go BE to AB. Okay, that one's right. I wonder if this was supposed to be right. If this was supposed to be right, what would it have to be? It would have to be this, BE over DE. No, we got it right here. We got this one here. This one is this one. Look, AB over CD is BE over DE. I'm okay with this. Let's try two more. All right, DE over BE equals what? DE over BE. So, base of small over base of large. Now I would do height of small, CD, over height of big, AB. We're staying in a consistent order, and sure enough, this is CD over AB. This is good. CD over AB. So, CD over AB, right? We're going height of small to height of big equals. How about base of small, DE, to base of big, BE? So, no. DE, yep. Ding. So I get these four here. All right, I get these four. I do not get this one right because this one looks wrong to me. Right? AB over CD can't be. It can't be BE over DE here and DE over BE here. One of them's wrong, and it's this one. Right? So you're marking multiple answers, and you're definitely matching up the name of this video with the practice problem set you're doing. Otherwise, this whole system doesn't work. This is Geometry Semester 1. It is the unit called Similarity. It's the 8th unit. And it's the first lesson, Proportional, Proportion, Proportions, Practice on CreatorMath.com under the Geometry tab. Hope that helps.